I'm now going to do 3 problems from review number 2. The first problem is going to be problem number 2. We're given the center and the diameter of a circle, and we're asked 2 things. Write the equation of the circle, and then test this point, -3, 2, to see if it's inside, outside, or on the circle. So the first thing let's look at is the fact they gave us a diameter, which is nice, but we actually need the radius to help us write the equation. So if the diameter is 10√3, then that means the radius is simply 5√3. Now, in order for the x-coordinate of the center to be 5, then the equation had to have been x minus 5 squared. Same thing for the y of -2. In order for the y-coordinate to be -2, the equation had to have been y plus 2 squared. Opposite, opposite. Now, all we need to know now is, what does the equation equal? Well, this is r squared. That's what goes right here. So all we got to do is figure out, how do we take 5 square root 3 and square it? So outside, 5 squared really is 25. Square root 3 times square root 3 is simply 3. So that's 75. So that's what we put right there. Now, let's just test this point to see whether it's inside, outside, or on the circle. All we're going to do is substitute. We're going to go back to the equation, and we're going to put a -3 in that x position right there. So -3 minus 5 squared. And we're going to do the same thing for that 2 right there. We're going to plug it in right where it says y. 2 plus 2 squared. And we're going to evaluate it against the number 75. So I'm going to put a box there, because we don't know, is it going to be less than, equal, or greater than? That's what's going to help us. So -3 minus 5 is -8 squared. 2 plus 2 is simply 4 squared, box 75. So 64 plus 16 is what when compared to the number 75? So 80, 75, box, and I know a greater than symbol goes right there. So the answer is outside. In the previous video, where I did some problems from review number 1, I did a problem similar to this, but the focus and the directrix didn't put the vertex of the parabola at 0, 0. This one does, so this is actually going to be an easier problem. We know the focus is at -5, 0, so let's mark that. -1, -2, -3, -4. Here's -5, 0. Right there. The directrix is at x equals +5. So what we're going to do is we're going to draw a vertical line right up and down at x equals 5. There's your directrix at x equals 5. And like I said, that tells us the vertex of this parabola is sitting right there at 0, 0. It has to be, because the focus and the directrix are equally distant from the vertex. So if this is -5 and that's +5, then the middle must be 0, 0. So I'm going to put my vertex right there. Now, I'm also going to open up my parabola. So, there's the parabola. We know it opens to the left because the focus is always inside the parabola. Now, what we also need to do is pick a point on the parabola anywhere. So let's pick a point like right here. We have no idea what the ordered pair of that point is. So let's just call it x, comma, y. Now we do know what that is. Remember that was negative 5, 0. We're going to use the definition of the parabola that says every single point on the curve is equally distant to the directrix, right here, and to the focus. So those two distances are equal. So that means we need to do the distance formula. Let's do the distance formula from the selected point to the focus. So I've got square root x minus 5 squared plus y minus 0 quantity squared equals, now let's go the other way, x minus 5, because now we have to think of what would that point be right there. Well, we really don't know what its y-coordinate is, but we know it's the same y-coordinate as that. And we do know that it would be 5, because we know the x value is 5. We just don't know the y-coordinate. So the distance formula from here to here would be x minus 5 squared plus this y minus the same y, so y minus y squared. So everything from here on out is just going to be doing some algebra, but the setup is the distance from the point on the curve to the focus, which is illustrated right here, is the same as the distance from the point on the curve to the directrix, which is right here. So now all I have to do is start simplifying. I'm going to make this x plus 5 squared plus, now y minus 0 squared is simply y squared equals, now over here, x minus 5 squared. Okay. But y minus y is 0, and 0 squared is still 0. Now the next step I'm going to do is square both sides, which is simply going to get rid of the square roots. So now I have x plus 5 squared plus y squared equals x minus 5 squared. Okay, the next thing I'm going to have to do is I'm going to have to expand my square. I'm going to have to FOIL this out. X squared plus 10x plus 25 plus y squared equals x squared minus 10x plus 25. Now, there are some nice things that are going to happen at this point. I have an x squared on this side, and I have an x squared on that side. So those two things are going to cancel each other. I have a 25 over here that's positive, and I also have a 25 over here that's positive. So those are going to cancel each other. The only thing I have that really doesn't cancel each other, this is a positive 10x and that's a minus 10x. So I'm going to combine like terms. I'm going to move these positive 10x's over here. And now the only thing left on the left-hand side is y squared. So y squared equals negative 20x. Now, that's focal width form. If you wanted x equals form, then all I need to do is multiply both sides by negative 1 over 20. Or another way of saying it, divide both sides by negative 20, and you would get negative 1 over 20 y squared equals x. So those are the two common forms we've used. Focal width and descriptive. The last problem I'm going to do for review number 2 is problem number 10. Now we're given the equation. We know it's a parabola because x is to the second power, but y is only to the first power. We also know something about what kind of a parabola it is. I've got y on the left-hand side that is only going to the first power, and I've got x squared on the other side, and it's going to the second power. So I already know y equals x squared, and the leading coefficient of that x is actually positive. So that already tells me something about this parabola. It's a parabola that's ultimately going to look like this. It is an up parabola. But there's a lot I don't know. For instance, I can't look at this equation and figure out what the vertex is. And we all know what that means. When you can't do that, it means you're going to need to complete the square. So that's what we're going to do. We're going to start the process of completing the square. Now the left-hand side, 4y minus 14, doesn't really need to have anything done to it. The right-hand side, I need to factor out the 2, and I'm left with x squared. Now if I divide that by 2, minus 2x, but then I'm going to need to complete the square. So half of negative 2 is negative 1. Negative 1 squared is positive 1. But because of that leading coefficient, I don't just add 1 to each side. I add 1 times 2, so 2. To keep the equation balanced, I actually have to add 2. Now, the next step would be 4y minus 12 equals my leading coefficient that I factored out, and then the perfect square that I just created. And that perfect square is x minus 1. Now, I'm going to move that minus 12 over to the other side, and now I have 4y equals 2 times x minus 1 quantity squared plus 12, because that negative 12 moved over there. And now I'm going to divide everything by 4. So this gets divided by 4. Both of these terms get divided by 4. And now I have y equals, now 2 over 4 is 1/2, so that's the leading coefficient of my x minus 1 squared. But 12 over 4 is 3. so plus 3. So there's my final equation in its descriptive form. And the reason I like descriptive form is because it tells me exactly what the vertex is. The vertex is positive 1, positive 3. So I'm going to go ahead and mark that vertex. 1, 1, 2, 3. So there's my vertex right there at 1, 3. Now I also know there's a focus up here and there's a directrix down there. Both of those things are contingent on the C value. So C equals 1 over 4A. C equals 1 over 4 times the A value, which is the leading coefficient, which is 1/2. So C equals 1 over, 4 times 1/2 is 4/2. And 4 over 2 is 2. So C equals 1/2. And C tells me how many steps I have to go up to get to the focus and back to get to the directrix. So if I'm at 1, 3 and I go up a half a step, I'm now at 1, 3.5. Now, if I put myself back at 1, 3 again, and I go down a half a step to get to the directrix, that means my directrix is now at y equals 2 and 1/2. Because here's my parabola. Here's the vertex of my parabola. I know it opens up. And now my focal chord endpoints. My focal chord endpoints are based on 2C. Well, if C is 1/2, then 2 times 1/2 equals 1. So I'm going to get to my focus, which was 1, 3.5 right here. And I'm going to go one step to the right and one step to the left to get to my focal chord endpoints. So if I go one step to the left, I'm at 0, 3.5. Let's set myself back at the focus again. If I go one step to the right, I'm at 2, 3.5. And that's the end of problem 10.